Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSS sheet. In this we were doing tree topic and pattern was DFS traversal. In this video we'll see the next question, which is very important from a fresher level, which is diameter of a binary tree, and in this video we'll see both codes, means via BFS also and via DFS also. Means as a beginner it is very difficult to understand कि we should apply BFS traversal or we should apply DFS traversal. So we will learn using both of these approach, and also we'll see कि which approach uses what complexity and on what questions both are preferable or any one of it is preferable. So let's read the problem statement. It says we'll be given a root and we have to return the length of the diameter. Now, what is the definition for diameter? It says it is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. Okay. What does it mean? See. Diameter says कि for any node, the left path sum and the right path sum. If you see for two node, what is the left path sum? 1, 2, 3, 4, 5, 6, right sum. Means in total left plus right is 6. So can I say for 2 it is 6. Now similarly think for 1. 1 has multiple paths, this path also, correct? Or else this path also towards its left. Means for 1's left we had 3 paths. But out of all 3, what is the maximum path? That is 1, 2, 3, 4. Correct? This way also if you would have went 1, 2, 3, 4 only. So can I say from left we got 4 and from right we got 1. So in total 5 for this node. Similarly for 3, how many nodes, like how many paths are there for left? 0. For right? 0. So it has 0 paths. Similarly for 4, how many paths are there in left? 2 and in right? 0. So in total 2. Now for 9, 0 for left side and 1 from right side. So 1. Now for 10, it's 0, nothing in left and right. Similarly for 5, we have 1 from left side and 2 from right side. So can I say in total 3? For 6, it is 0. For 7, left side 1, right side 0. Now for 8, left side, right side 0. So out of all the nodes, which one is the maximum one? Can I say for 2? And that's what diameter is. 1, 2, 3, 4, 5, 6. Okay, the paths we have to give, not the number of nodes. Number of nodes, if you'll see, they are 7. The paths we have to give, which is 6. Okay. Now the second line, what it said, कि this path may or may not pass through the root. It means, if you see here, the diameter means this path has not crossed the main root. Okay. So that's what, it does not mean कि the path, the diameter, maximum diameter should pass through root. No, it can pass through anywhere. That's what it means. Now the length of the path between two nodes is represented by the number of edges, not nodes, as said. Okay. Now let's see the constraint. It says the minimum number of nodes will be 1, means there will be minimum 1 node, means no need to write the base case for BFS. For DFS, so we have to write, and you know why? Because we keep on moving recursively in the same loop. So to come out of it, it's very important to write. Okay. So, and the maximum number of nodes are 10 power 4. Okay. That we'll see later. Now the number of node values, why this has been given? See, if we do multiplication or division or subtraction, it is very important to read the values also. But here we have nothing to do with node values. So we don't need to worry. But when do we need to worry? See, if it has been given ki 10 power 6, 10 power 9 or so on, it can go till there. So you know integer can hold up to at max 10 power 9 values. Beyond that, if you have to do any single addition to it, you have to convert this into long format. So that is why we always read the constraint values also. But here we have nothing to worry with the values, because here we are focusing on counting the edges. So it's okay to go with. So now as we have understood the problem statement, we'll see how we will do this. We have two ways. We have learned two ways as of now in our previous videos, DFS traversal and BFS traversal. Now let's try to do with this BFS traversal. BFS traversal says, see, you saw na कि for every node we have to count the maximum edges for every node, and out of all we have to return the maximum. So in the BFS traversal, can I say I'll start from this node? So in my Q data structure, I will append the very first node, 1. Okay, now next time I'll pop. Okay, but for this node, can I say I know what is the diameter? Until or unless I would have traversed the entire tree from the left side also and from the right side also. Yes. So can I say whatever node I have popped from the queue, for this, make a function, go towards its left side, go towards its right side and tell me what is the maximum number of level. But wait, level? Why level? See, for 1, we want left or right now. So for 1, send this as a node and ask its maximum number of level. So 2 will say I have 1 level, 2 level, 3 level, 4 level, correct? So if either it has suppose 10 here also, so 5th level. So for 2 will say, hey, I have 5 levels in me. So 2, like from 1's left, it is 5 levels. From 1's right, if you will call and apply that breadth first traversal for level or traversal, which we have already discussed in our previous video. So it will say, hey, I have only 1 level. So once right is saying I have only 1 level, means can I say I have only 1 edge? Once left is saying I have 5 levels. But for this tree, if you see 1, 2, 3, you will say it's so number of edges are only 3. But see, this we are not counting now. So that is why I said ki go and check the levels. Okay. So levels will be, it will count the number of nodes at that level. Can I say? So 3 edges, but we want to count this also. Okay. So hence just say ki how many levels are there. It is 4. So okay. So from 1's left it is 4. From 1's right it is 1. So in total 5. So wherever we have popped now, like we have popped first node and we have sent, like make a function call to count the left level and right level, and whatever we got we will return, correct? And we will update our diameter with 5. Okay, we will update our diameter with 5. So can I write the code also ki while my queue is not empty first. Okay, now pop this. So let's say tree node queue dot poll. I'll pop. Now I have this node. What I want left levels and right levels. Let's call it height. Height means this will give me height only, na? Like 1, 2, 3, 4. Correct? So let's make the function name height. So we'll call that function height by sending root dot left. So root dot left will bring how many number of levels are there from the left side. Similarly, call the height with the root dot right. Now it will give me how many levels are there from the right side. So we'll save also because it will return our integer, right? So left and right. Now whatever diameter we have, let's initialize the diameter with 0. So can I say my current diameter will be math.max whatever current, like whatever was previous diameter, or else this one. This one is nothing but left plus right. That's it. Can I say that? So for 1, I have called a height function. I'll write the code for that. But I have called one height function for left side, for right side. This left side has given me how many levels I have, because levels are nothing but I can say height. And from here also 1. So this side 4, this side 1. So in total 5. And that's what I got. 1, 2, 3, 4, 5. Or else 1, 2, 3, 4, 5. Does not matter. Like which path you are choosing, it's not necessary. But what is the longest path you are choosing, that's necessary. Okay, done. So now can I say for 1 I am done. And what is my current diameter? Can I say 5? Okay, I'll update. Now next time, what do you think? 2 and 3, correct? For 2 also I want, for 3 also want, correct? So in my queue, can I add 2 and 3? But only after seeing if it exists. Means what if 3 dot left does not exist? Means it is null. And if you will insert null here, when you will pop, you will call the function height with null dot left. It will give you null pointer exception. So hence it is very important to insert only those nodes in our queue which are not null, correct? So can I write here ki if my root dot left exists, then only in queue offer root dot left. Can I say that? Similarly, if my root dot right exists, then in queue offer means add, okay, root dot right, and that's it. Now I don't know what height is doing, but for sure this much line of code will give me the diameter for every nodes, and this line code, diameter is equal to max.max, diameter or left plus right, will keep on updating my diameter with the maximum diameter so far. So can I say after coming out of this while loop, I can return my diameter here, return diameter, okay. Now the thing is, what does this height function is doing, okay. So when we are sending this root.left, so can I say for height, I have got one root, correct. For that root, I just need to perform level order traversal, what we did previously. I will attach the link somewhere here. Key, we called this, now next time this, now next time this, now next time this. So in total, we made total 4 sublists. So the length of sublists are nothing but number of levels or heights. But in that case, you will end up wasting your space complexity also, because you are storing everything, right? We don't need to store the nodes also. Then what do we need to do? So guys, if you have understood the previous question, which was level order traversal, then definitely you will be able to understand this much line of code. Let's discuss that. So in the level order traversal, it says ki insert your 2 node and until your queue is empty. This is the new queue, okay? Until your queue dot is empty check will do first, okay. First, we will calculate the size. Why we calculate the size? We already discussed in our previous video. So I am assuming you all know how to do BFS traversal, okay. Then first we will calculate the size, okay, queue dot size, and for that many number of times we will run the for loop, remember. So we will run the for loop for int, for loop or while loop, whatever you are comfortable with. Int I is equals to 0, I less than size and I plus plus, correct. And in that loop we have to pop our node. So tree node is equal to queue dot poll. We have popped. Now what we want to do with this? Nothing. We don't need to print this node. We don't need to do anything. It was just about running the for loops for all the levels. So whenever we are changing the for loops, I'll keep on incrementing my count. Why? This for loop will run for one time as of now. So I can say this is my level 1. Can I say? Or height. So let's initialize height somewhere here with 0. And when we did this, after coming out of this for loop, we'll simply do height plus plus. Done. Now see, we have popped 2. Now what are we supposed to do? We have to append this left node and right node in the queue. That's what we do in the BFS traversal. So we'll insert 3 and 4. That's it. So here we will check if our node dot left exists. Then similarly in queue add what? Can I say node dot left? These are very similar. Repetitively we will have to use, like we have to use that. Node dot right exists. Then similarly in queue, yes, offer node dot right. Now what we did here? For 2 we added 3 and 4. So we have added 3 and 4. Now what will happen? Next time this for loop is over, right? Right. Now next time again we'll go and queue dot size will calculate. This time this for loop is supposed to run for 2 times. 3 will get popped and its children will get added. We have nothing, so nothing will get added. Next time 4 will get popped and its children will get added. So 3 popped, 4 popped and 4's children will get added, which is 5 and 6. Now this for loop is again over. Now again height plus plus. Now next time height 1, next time height 2. Again height plus plus. Again we'll check queue size 2. This for loop is supposed to run for 2 times. Now again it will run. Pop 5, add the children, nothing is there. Pop 6, add the children, nothing is there. For loop is over. Again height plus plus, means this time height is 3. Now queue is empty. Yes, queue is empty. Now after coming out of this whole while loop, can I say return this height? Why return this height? Because that's what we called here, na. We have sent for this node 1, we have sent root dot left. So we sent 2 and this height function has all actually helped me to tell me what is the height of this tree. So height, so here we'll get 4 as left, here we'll get 1 as right, and that's what we do. 4 plus 1, 5. So for one node the diameter is 5. So we'll update our diameter from 0 to 5 and that's it. And we'll add 2 and 3. Next time from the queue 2 will get popped. Again for 2 we'll send this. So the level order traversal height will give me 1, 2, 3 height from the left side and 1, 2, 3 height from the right side. So if you see the time complexity here, first of all, this while loop is running for every node. Can I say O of n time complexity? Yes. So n is 10 power 4, so it will be 10 power 4. Now inside this also, for every node, you are sending n by 2 calls here for the left side, n by 2 calls here for the right side. Now don't think here though it is more, here it is only 1. In this case, the design is like this. So can I say if it is a balanced tree, means you have all, equal number of nodes like this. So can I say for this one node, you have called this and you have called this. So this will take n by 2 time complexity. This will take n by 2 time complexity. Now why this tree is taking n, like in total n by 2 means because of, according to this whole n. But in total, if you want to calculate this, like the level or traversal, here if you go, what you did? In Q, you have added all the nodes, can I say? Here also O of n space complexity, correct? And also the for loop, like here also you are going on every nodes one by one. This while loop and for loop together is running for every node. So in total, it is nested. So time complexity will be n square. If the constraint is 10 power 4, n square will become 10 power 8. The code will be very slow, okay? If it was 10 power 5 now, it would have become 10 power 10. Definitely the code would have gave us TLE. How I know? Because regarding the time and space complexity, we have discussed in our full YouTube video. I'll attach the link somewhere here. Okay, so this code we can submit, but as per the time complexity, it is very slow, and space wise also you are using 2n space. 2n space means first O of n by this while loop, second O of n by this height function to calculate the number of levels. Remember? So O of 2n space. So it is not optimized. Okay. So let's write the code in our editor for BFS approach. Here is the code what we have discussed. First, so we'll do the base case and we'll initialize our diameter with 0. Then we will start our queue, make our queue, and the queue will offer the root. Until it is empty, we will pop the first node, call the height for node.left, node.right, whatever the value we have got. In the diameter, we have to check whatever is maximum, the previous one or the current left height plus right height. Okay. Once done, we have to append its left child and right child for the next calculations. Now in the height function, what we are doing, again whatever node you have sent, add the base case if you need. Now create the new queue, because here we want to calculate the levels, which is height. Initialize height 0 until queue is empty, calculate size, run the for loop until that size, and do height plus plus after coming out of this for loop, because this for loop is supposed to run for all the nodes in that particular level, which is, for me it is just one height. Okay. And after coming outside, just return height, and that's it. So let's run the code, and when we will submit this, you can see the code will be very slow because of n square time complexity. Okay, as you can see, yes. So now this was the code in Java. Here is the code in C++ with the similar approach, and here is the code in Python for the similar approach. So if you understood this, now it's time to go for the DFS approach. So in the DFS approach, what we are supposed to do? See, the concept of nodes will be as it is, like the concept of diameter. Remember? Yes. But I can say one thing for sure, if you remember. What is that? If I am standing at node, what does DFS means? DFS says go towards left, 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 deeper left. If it is null, come back and then go towards right. Return, then go towards right. Return, then go towards right. Correct? If I am standing at node, okay, in pre-order, in order traversal, we were supposed to do something with the node itself, then go towards the left and right child, remember? But here if you are standing at 1, can I say what is my diameter? We just saw in the BFS also, no. We need to go down and down to get the information key what is my level below the nodes. So I can say for sure one thing, ki if I am at node, I cannot decide anything. I have to go towards my left child or right child, wherever I want to go. Okay, so DFS function will have root. First I will check if I have, like if my root is not null. If my root is null, return, then and there. Correct? Okay, can I say 0? Why? Because see, I am waiting for my left node to give me an integer value so that I can add with my right node. Okay, if I will return null, how you will add this null with the 1? Like suppose for 3, for 3 when you will go left child and right child, if it will return null, null, how you will add? So it is very important when you are doing this integer summation or when you are doing the boolean type of things, it is very important what you are returning. Okay, so if you have to return true false when the root is null. If you have to return something like where you have to add it, return 0. I hope you know that. Now if my root is null, no, my root is not null. Now what I am supposed to do? Do I need to do something with the root, or I should go towards my left or right child? Go towards my left or right child, correct. So can I say I'll call the same function DFS with the root dot left. I'll call the same function DFS with root dot right, correct. Now can I say one thing, because this is returning when it is null, so for sure when I am calling it will get some return value, so we should store also. Yes, so we should write int left, int right. Done. Now let's go for 1 left, 2 left. Why? Because you are just following in the same first case. You will not go for the second line of code until this function has been returned, correct. So 1 dot left 2, 2 dot left 4, 4 dot left 9, now see 9 dot left. So you will call 9 dot left. So let's make the stack calls also one by one together. Okay, let's see, here is our stack. Function 1, 1 dot left function 2, 2 dot left function 4, 4 dot left function 9, 9 dot left function null. Okay, so can I say it will go and it will say, hey, root is null, return 0. So left will have 0. Yes. Now we will go for root dot right. What was my root? 9. Root dot right 10. Correct. Listen it very carefully. 10. Again, let's write it. It has been returned, right? So we have been called for 9 dot left. Now it will be 9 dot right. So function 10. Now for function 10 also, left side which is null. So if you will go for left side, you will get 0. Now you will go for right side, it will be 0. So can I say at this point of time, I have 0 left, 0 right. So for 10, think it very carefully. Forget about all those nodes. Just think like this is a tree you have. You have left 0, right 0. What is the diameter you have as of now? For 10, what is the diameter? Can I say left 0, right 0? Means for this tree, you have no edges. So can I say diameter is 0? So can I say diameter is equal to math.max, your current max diameter, or else left plus right. Can I say that? Yes, yes. Now listen it very carefully. For this, the diameter is 0. Done. Very good. But if you will return this, now the thing is what you will return. If you return the diameter, suppose 0. So 9 dot left will say, hey, I have 0. 9 dot right will say, hey, I have also 0. So do you think for this much tree, forget about the further trees, just think about this tree. For 9, what is the left number of edges? 0. What is the right number of edges? 1. So 10 should return 1 na? For 9's diameter, because diameter you are calculating for 9 also you will get left 0. You should get right 1. Then only for 9 the diameter will become 1. Correct? So what should you return? What do you think? Think again. If you are still confused, think like this. For this 2, when you have left also, right also, think. 2 needs to return the longest path to 1, correct? Because from 1's right side, the edge is only 1, okay? But from 1's left side, it has 3 paths, 1, 2, 3. Can I say that? Means from 1's left side, it has this path also, and this path also. But it will consider only 1. Can I say? Yes. So 5 should return this path, or 5 should return this path to 2. Can I say 5 should return this path? Okay. Now 2 should return this path, or 2 should return this path. Both are same. So what are they returning? Can I say 2 is returning nothing but max of left comma right plus 1. Again, max of left comma right plus 1. Yes. So we will return map.max left right. Yes. So now you will come here. 10 has left 0, right 0. Correct? Plus 1 for this. Plus 1 for this. So it will return plus 1. So now it will return plus 1. So for 9, see, 10 has to be removed, null has to be removed, yes. 10 has to be removed, yes, from the function call. Now we are at 9. We are at 9. So after this line of code, it will also return. So at 9, what will happen? At 9, diameter will be calculated left plus right. So left is 0, right is 1. So as of now, what is my max diameter? 1. Now what the 9 will return? 9 will return dot max of left, which is 0, right, which is 1. So maximum is 1. Now plus 1 for this. So 9 will return 2 to 4. So for 4's left, it is 2. From 4's right, it is 0. So in total, max is 2. So it will return 2 and plus 1 for this. Yes. Can I say? So mat.max. So for this, the maximum diameter is this and here 0. So total 2. Now we will return and here we will get 3 from 2's. So let's remove function 9. Function 9 call. Function 4 call also has been returned. Now we will go for 2's right. 2's right means now 5 will get inserted. Means function 5 will get inserted. Now what will happen? For 5, again we will call for left side. So from 5, function 6 will get called. Now from 6, left, which is null, will get added, it will get returned. Now 6 right, again null will get added, it will get returned. So for 6 left and right, we have got 0, 0. Again the maximum diameter is, as of now, what is the maximum diameter? 1, 2, this 0, remember? So 4 has maximum diameter. Now it has returned 3, but 3 is not diameter, 3 is the maximum height from left side. Now until the 2 gets maximum height from right side, we cannot say what is the maximum diameter for 2, right? Okay, so now again we will get 0, 0, maximum diameter will still be 2. Now we will return maximum of left right, which is 0, 0 and plus 1. So 5 will get 1 from left. So 6 will get removed, yes, and 5 will get what? 1 from left side. Now we will go for right side. So function 7 will get called. Now for 7, left call, which is function 8 will get called. Again for 8, left 0, right 0, maximum is 0, but it will return plus 1. So from 7's left it is 1, from 7's right it is 0. So function 7, 8 will also get removed, 7 will also get removed. So now for 7, the maximum diameter is 1, but as of now maximum is already 2, so diameter will not get updated. But what 7 will return? 7 will return left, right, whatever is maximum. So left is 1, right is 0, so 1 and plus 1, which is this. So 5 have got 1 from left, 2 from right. Okay, so 5 will say diameter is left plus right, which is 1 and 2. So maximum diameter is, as of now, 3. Very good. 5 will get removed from the function call. Done. And what will be returned? Left 1, right 2, plus 1. So 5 will return this path and plus 1. So 5 will return 3 to the 2 and 4 has returned already 3 to 2. So can I say 2 has left 3, right 3. So maximum diameter is, yes, 6. Now 2 will return only the longest part. See, we have calculated the maximum diameter, but 2 can only return one single path for 5, either this or this, correct? So hence for 2 it will return maximum of left side, right side plus 1. Yes. So from like 2 first, 2 will get removed. Now for 1's right side will get called. Now we will call for 3. 3 is left 0, 3 is right 0, 0, 0, maximum diameter is 0. It will not get updated. Now it will return left right maximum, which is 0, 0 and plus 1. So from 1's right it is 1. From 1's left it was, remember, 4. Why? Maximum, which was 3 and plus 1, 4. So for 1, diameter is previous diameter 6, comma, left 4 plus right 1, 5. But it will not get updated because 6 is a still maximum. Now what will get returned to its parent? Not necessary, but again as it is the general return statement, so we have to return. So what will get returned? 1, 2, 3, 4. 1, correct? Maximum of this or this, which is 1, 2, 3, 4, 4 plus 1, which does not exist actually, but still we will return 5. Anyhow, it was not required. This was required, which we were updating in our variable. So after this, wherever we have called this DFS function, we will not store anywhere. Like the return statement will not store. We will simply call the function and after that we will return the diameter, and that's it. This was your DFS call. So what is the time complexity? You have visited all the nodes at once. And we have saved all the node calls in our stack. So space complexity is O of n, time complexity is O of n. That's it. And in BFS it was n square. So this is far better approach. I hope you understood. Now let's write the code. Okay. So first we will initialize our diameter variable globally. Let's initialize with 0. Now we will make a function, let's say height, height, and we'll send root here, and after coming outside we'll simply return the diameter. Why? Because diameter would have stored our value, correct? Now we'll make a private function. Private integer type will be returned, name will be height, and we'll get the root. Okay. Now first thing which we have to do is we have to write the base case, correct? If we are at any root which is null, then we will return 0. Why? Because the return statement is integer, remember? Okay. Now after this we'll call for height, go towards left side. Okay. Similarly height go towards root dot right side. Done. But as both will return something, so it is very important to store in our left and right variable. Remember? RIGHT. Done. Correct? Now after this we have to update our diameter. Yes. So diameter is equal to math.max. The current diameter is maximum, or else left plus right is maximum. After this we have to return. So return statement was math.max. Remember? Yes. Left side or right side and plus 1 because of that current edge. Done. And that's it. Now let's run the code. Private, okay, sorry, my bad, tree node. Type was tree node, right? Now let's run this. Now let's submit this. So as you can see, it is faster code because the time complexity is linear, O of n, and it was 10 power 4, so of course it will be faster. So this was your code in Java. Here is your code in C++ with a similar approach, and here is your code in Python with a similar approach. So if you understood both approach, BFS and DFS, and I hope you understood with the time complexity, and for this code, depth first search has actually won the race. Okay. So if you understood, we can go in the sheet and mark the next question, which is diameter of a tree as done. So I hope you understood. If yes, please do let me know in the comment section, and please do hit the like button and subscribe the channel if not yet subscribed, because that gives me more motivation to make more such wonderful videos for you all. And that's it. I'll attach the link of the sheet and the social media link so that you can reach out to me for any guidance in the description. And that's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. Till then, keep learning, take care of yourself and your family too.